Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
Two technique exercises will be demonstrated. A gold technique exercise constructed of .038 diameter wire with a gold butt joint, a gold mershon post, and a stainless steel hook soldered to the main gold wire. A stainless steel butt joint will also be constructed. Stainless steel solder, joining two pieces of .030 diameter stainless steel wire. The first step in soldering technique is the lighting of the orthodontic blowpipe to obtain the necessary heat for the soldering process. To light the orthodontic blowpipe, the air side of the blowpipe is opened completely. The gas side is opened about a half of a turn. The gas valve on the bench is opened completely, and the flame at the blowpipe is lit. The gas is turned up, and the air valve on the bench is then opened until there is a hissing sound, or the flame itself begins to be blown. At this point, you begin to reduce the amount of gas and reduce the amount of air as needed to establish the right height for your soldering flame. For gold to gold soldering, you want a hotter flame, more hissing sound, a little larger. For stainless steel soldering, you want a little cooler flame, a little smaller. To make the gold butt joint, the first step is to file off the end of a piece of .038 diameter gold wire with the lab file. The next step is to add the gold soldering flux to the end of the wire. A hand instrument is used to add this flux to the areas where you want the solder to flow, only on the end of the wire. Gold solder is used for this procedure. To add the gold solder to the end of the wire, you hold the end of the wire in the soldering flame, heat that wire, and then touch the gold solder onto the end of the wire itself, forming a small half a ball of solder. To make the gold butt joint, you file off the end of another piece of .038 diameter gold wire and add a little bit of flux to the end of the wire itself. To make the solder joint, you put the heels of your hands together and hold the two wires into the proper alignment. Move it into the soldering flame and hold it there until the solder flows. You can usually see the solder flow. When the solder is flown, you remove the wires from the fire and let the solder joint cool. Ideally, you want a solder joint that is strong, will not break when bending forces are applied, and you want a solder joint that is smooth and continuous, free of pits and surface defects. To add the mershon post to the main wire, you place the flange of the post onto the main wire and squeeze it into place with bird beak pliers in the position that you want it. You then add gold flux to the flange area. You add flux only in the areas where you want the solder to flow. The entire edge of the flange is fluxed. To make the solder joint, you hold the post into the soldering flame and touch the orthodontic solder, gold solder, onto that flange. The solder flows around the edge of that flange and secures it to the main wire. The solder should be limited to the flange area in the main wire. No solder should flow down onto the shaft portion. This shaft fits into a precision fit tube in the final construction of the orthodontic appliance. A second type of mershon post is added to some types of Porter and lingual wires, a mershon post without a flange. To add this type of mershon post to the main wire, you grasp the posts with soldering forceps and you use a lead pencil to anti-flux the sides of the shaft. You then add some gold flux onto the end of this little length of shafting and set it aside. You add flux to the main wire where you want to add that post and touch the solder to the area that you've fluxed. To add the mershon shafts onto the main wire, you position the posts directly at a 90-degree angle to the main wire, right on your solder that you've added, and move them into the soldering flame. You can see the solder flow as the solder joint is being made, joining the two pieces of metal together. For this type of solder joint, you want to be sure there's a very strong bond between the shaft and the main wire. The solder should be smooth and continuous and free of any pits, surface defects, and it should flow all the way around the back side and the front side of the mershon posts. Lastly, there should be no solder flowed down onto the post itself. Again, this section fits in a precision fit into a tube in the construction of Porter and lingual wire appliances. To add the stainless steel hook onto the main wire, you first bend a 2mm tag onto the end of the piece of stainless steel wire. You then add stainless steel soldering flux to this little tag or foot of wire. For soldering stainless steel wires, an excess of flux is used in contrast to the gold soldering. A lot of flux and a greater amount of solder is used in making a stainless steel solder joint. You use stainless steel solder for this procedure. To add the solder, the same technique is used. You put the wire into the flame and touch the solder onto the wire, flowing a fairly good amount onto that little foot. To add the stainless steel wire to the main gold wire, you flux the area on the gold wire where you're going to add the stainless steel hook, and hold that soldered foot of the stainless steel wire right onto the spot where you want to make the joint. Move it into the soldering flame, and when the solder flows, move it out of the flame, and there you have your stainless steel solder joint onto the gold wire. The final product should be smooth and continuous, free of pits and surface defects, and it should completely cover the foot of the stainless steel wire, going all the way around the wire. There are some problems that can come up in soldering stainless steel wire. One of them involves overheating a stainless steel wire. If a stainless steel wire is heated in a soldering flame too long, it becomes dead soft. It becomes annealed. And when it's red hot like that and then cools, it loses its properties of elasticity, and it will bend very easily on the spot where it was overheated. You want to avoid that type of overheating in construction of any stainless steel wire solder joints. To make the stainless steel solder joint, butt joint, you flux the end of a 030 diameter wire and add solder onto that fluxed end. A fairly large amount of solder is added on to make this stainless steel butt joint. The other end of the 030 diameter wire is fluxed, and to make this solder joint, you're going to roll the wires over one another to get that solder flowing, and then pull them out end to end so that the solder can flow and they can be well aligned. The completed solder joint should be smooth and continuous, free of pits and surface defects. There should be sufficient bulk to give it strength. And the wires should not be annealed, in other words, not overheated in the soldering process. You should be able to bend the wires, and they should retain their properties of elasticity. You flux the end that you're going to add in, and what you're going to do is put it in the flame and rotate them around one another to get that solder flowing, and then you're going to pull them out into an end-to-end position. Solder joints can be polished, the flux cleaned off, with pumice between your fingers. You rub the pumice back and forth over the solder joint, and excess flux and oxides are removed. You can then check your solder joint to be sure that it's smooth and continuous, free of pits and surface defects.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.